Hello and welcome to the launch broadcast for They Go Up So Fast, Rocket Lab's 19th Electron mission. It is Tuesday, March 23rd here in Auckland, New Zealand, where we're joining you from Rocket Lab's Mission Control Centre. We're in the final minutes of the countdown to liftoff from Launch Complex 1, currently scheduled for 11:30 New Zealand time. My name is Muriel Baker and I'm the Senior Communications Advisor here at Rocket Lab.
And I'm Scott Moeller. I'm the Propulsion Engineering Manager in the Propulsion Development Department for the Electron's 3D printed Rutherford engines, and I am thrilled to be joining you for another Electron launch. Today's mission is a special one, as it will tip us past 100 satellites deployed for our incredible customers. With 6 satellites on board, plus our very own Photon spacecraft, today's deployment sequence will take place in 2 parts. First, Electron's Photon spacecraft will act as a kick stage to deploy 5 satellites to a 550-kilometer circular orbit. Then, we'll use Photon's Curie engine to lower the spacecraft's orbit to 450 kilometers for the final customer deployment. From there, Photon will remain on orbit to build flight heritage ahead of an exciting mission to the moon for NASA this year. But more on that later. We're proud to be welcoming some repeat customers onto Electron again for this mission, and we're also excited to work with some new ones.
One of the repeat small-sat operators and the first payload manifested for this launch is Earth observation company BlackSky. Their Gen 2 spacecraft will become part of a constellation to deliver real-time global monitoring from space for public and private organisations. We've also got 3 Australian small satellite operators on board Electron today. The first is from Fleet Space in South Australia, who first flew on Electron in 2018 on our It's Business Time mission. Fleet Space are building out an Internet of Things constellation in low Earth orbit, which their Centauri 3 6U nanosat on this mission will soon join. This satellite will also support the 2023 Seven Sisters mission out of Australia that will investigate new resource exploration techniques for Earth, the Moon and Mars in support of NASA's Artemis program.
The next Australian spacecraft is the Myriota 7 satellite, another Internet of Things smallsat. Myriota's mission is to provide access to data from anywhere on Earth for those working in the utilities, transport, and logistics space. The third Australian satellite is the M2 satellite built by the University of New South Wales Canberra Space. Working with the Royal Australian Air Force for this mission, M2 will bring together technologies that cover Earth and marine observation, quantum computing, artificial intelligence, and communications.
Other satellites on this mission include the Very Hatchling 1U CubeSat from CareWeather, a company focused on saving lives through better forecasting of Earth's extreme weather.
And last but not least, we have an experimental CubeSat from the U.S. Army's Space and Missile Defense Command, or SMDC, flying on Electron today.
Now there's also one more payload on this mission that we're very excited to tell you about. We have a Rocket Lab Photon spacecraft on board. This will be the second of our in-house built customizable satellites launched on Electron, and we've named this one Pathstone. Like Photon First Light before it, Pathstone will first perform its usual kick stage responsibilities of deploying our customer satellites, before making the switch to Photon mode and carrying on with its own mission in low Earth orbit. Here to tell us more about the Photon on this mission is Jane McNichol in our Rocket Lab Long Beach headquarters. It's great to see you, Jane.
Thanks, Muriel. My name is Jane, and I'm a Mission Integration Engineer here at Rocket Lab. I'm excited to be joining you from our Mission Operations Center inside our headquarters in Long Beach, California. It's from our production complex here on the West Coast, where our team produces more than 130 Rutherford engines and guidance and avionics hardware for our Electron rocket every year. It's also where our team builds our Photon spacecraft and operates them once on orbit from some of these consoles in the Operations Center that you can see behind me. Photon is pretty unique in that we can first use it as a kick stage from which to deploy our customer satellites. Then we can switch it into spacecraft mode to stay on orbit and complete secondary missions. Essentially, it performs 2 functions. First, as part of the launch vehicle, then second, on its own as a standalone spacecraft. After Photon has deployed all customer payloads on today's mission, it will remain on orbit to build flight heritage for hardware and subsystems ahead of our mission to the moon for NASA later this year. The Photon Pathstone launching today has several updated subsystems from Photon First Light, launched in August 2020. The primary technical and risk reductions and goals for Photon Pathstone will be to advance test the flight computer, test GNC algorithms and flight software updates, conduct radio and Doppler ranging testing, and also validate our own in-house built solar panels. All that testing will be used to inform our most complex spacecraft mission yet, the Capstone mission, which will see Rocket Lab place a satellite into lunar orbit for NASA. Capstone will serve as a precursor for Gateway, a moon orbiting outpost that is part of the Artemis program to return humans to the lunar surface. Today's launch is another step towards this thrilling mission that our team can't wait to see launched later this year. They're counting down the minutes to liftoff, and I'm eager to go join them, so I'm going to hand it back to you in Mission Control.
Thanks, Jane. Right now, we're at about T-minus 12 minutes and coming up to the go, no-go poll run by our launch director with our launch operators. That's due to begin shortly, so let's listen in now to Mission Control.
Come ups, come chicks.
Alright, in all stations LD on mission court at this time, we are proceeding with the go no-go sequence number 43. Stage, you go.
Stages go.
Avionics.
Avionics is go.
Avionics up.
Avionics up is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Met is go.
MM.
MM is go.
LDSUP.
LDSUP is go.
And exec.
Exec is go.
Stations LD on mission. The go no-go sequence is now complete. We are currently T-minus 11 minutes, 17 seconds and counting. I can confirm we go for terminal count at T-minus 10 minutes. Be advised from this time onwards, the 3-word hold procedure is in effect.
There we go. That was the green light we needed to launch, and we are go as we approach T-minus 10 minutes and 54 seconds until liftoff.
Now, when it comes to missions beyond Earth's orbit, there's still a lot to learn about how humanity will further explore our solar system. But there's one particular orbit near our moon that will be a great place to start. As Jane mentioned, Electron and Photon will launch to the moon for NASA later this year in support of the Artemis program. Photon will complete a series of orbit raises using its Hypercurie engine before deploying NASA's Capstone CubeSat toward its intended near rectilinear halo orbit, or NRHO, around the moon. There's a bit more about this exciting mission launching later this year.
Rocket Lab is supporting NASA's mission to return humans to the moon. Launching on Electron this year, NASA's Capstone cislunar satellite will orbit the moon, serving as a pathfinder for Gateway, a moon-orbiting outpost that is part of NASA's Artemis program to return humans to the lunar surface. Capstone's mission is to refine our knowledge of the dynamics of a unique halo-shaped orbit, paving the way for people to follow. The near rectilinear halo orbit, or NRHO, has an unobstructed view of Earth at all times, and also enables communications coverage of the lunar South Pole, the destination of NASA Artemis astronauts. Most Rocket Lab missions to date have deployed spacecraft to an orbit around 500 kilometers above Earth. But this mission will see us go a little bit further than usual, some 384,000 kilometers further. To get there, Electron will launch Capstone to an initial low Earth orbit. From there, Rocket Lab's Photon spacecraft takes over, providing in-space propulsion to conduct a series of orbit-raising maneuvers. This builds up enough velocity to perform a translunar injection, allowing Capstone to break free of Earth's gravity and set a course for the moon. After deploying Capstone, Photon will continue on its own trajectory to conduct a lunar flyby, while Capstone will use its own propulsion system to enter a cislunar orbit. Traditionally, smallsats have had to wait years for a rideshare opportunity on a large rocket in order to reach lunar and deep space destinations. With Rocket Lab, the smallsats call the shots, getting a dedicated ride to exactly where they want to go and on their schedule.
NASA is thrilled to be partnering with several small businesses to make this mission happen. That includes launch provider Rocket Lab USA, Capstone mission lead Advanced Space, The CubeSat developer, Tyvek Nanosatellite Systems, the propulsion system provider, Stellar Exploration, and several more. Together, we are expanding the reach of small businesses, small spacecraft, and small launch vehicles.
We can't wait to fly Capstone later this year, but for now we're just about 7 minutes away from our next launch, so let's check out the views of Electron on the pad down at LC1.
Understood, thank you.
LD, avionics terminal check, sequence 45 complete.
Understood, avionics, thank you. And please proceed with sequence 48, enable FTS for flight.
Commencing sequence 48. AFTS is green and enabled for flight.
Thank you, avionics.
Earlier this month, we made a pretty big announcement. How big? 40 meters big, to be precise. We confirmed that a new, larger vehicle, Neutron, will be joining the Rocket Lab family.
The medium-lift Neutron rocket will be a two-stage vehicle that stands 40 metres or 131 feet tall, with a 4.5 metre fairing diameter and a lift capacity of up to 8,000 kilograms to low Earth orbit.
Neutron's 8-ton lift capacity makes it the ideal launch vehicle to deploy satellites into batches to specific orbital planes, creating a more targeted approach to building out mega constellations. But just like Electron, Neutron is designed to lift payloads beyond low Earth orbit too. With a payload capacity of 2,000 kilograms to the Moon and 1,500 kilograms to Mars and Venus, Neutron will be able to enable important science missions beyond our own planet. Neutron will initially be designed for satellite payloads, but will also be capable of International Space Station resupply and even human space flight missions, which is very exciting.
We'll be launching Neutron from Virginia's Mid-Atlantic Regional Spaceport, located at the NASA Wallops Flight Facility, where Rocket Lab's Launch Complex 2 is located. Using this existing launch pad and integration infrastructure at Mars, that means we can accelerate the timeline to first launch, which, in true Rocket Lab style, is sooner rather than later, expected in 2024. And I think it's safe to say Peter won't be making any promises on eating a hat anymore, because that did not look tasty.
No, it didn't. But for this mission, we won't have a live view from Electron once the second and third stages separate, but we will be staying on air through the coast phase as the kick stage makes its initial pass around Earth to circularize its trajectory. About 10 minutes into this initial coast phase, our founder and CEO, Peter Beck, will be joining us for a Q&A session on Neutron, so be sure to stick around. After that, we'll come back to you with the simulation and confirmation of payload deployment, so make sure to stay with us.
It's now T-minus 4 minutes and 42 seconds to launch. Electron and its payload is healthy on the pad, and the weather is looking clear for an on-time liftoff. Let's hand over now to Mission Control to listen in to the operators in these final seconds to launch.
ECS is disabled, pad auto sequence is armed, pad is ready for launch.
Copy GC, thank you. stations, this is LD on mission. From now on, there should be no red flags on your critical LCCs. Beacon LD mission.
LD beacon.
Please confirm flight computer as goes a green.
Confirmed.
And please lock the auto sequence and confirm.
Locked.
Stations LD on mission, we go for auto sequence start at T-minus 2 minutes. And at this time, I can confirm LD is go for launch.
AVBs are on internal power. All stage power is disabled. The vehicle is on internal power.
LOX load is complete. System is in recirculation. Stage 1 anti-geysering is disabled.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge is enabled. Water deluge is activated.
Ten, 9, 8, 7, 6, 5, 4, 3, 2.
Stage 1 propulsion is nominal.
They really do go up so fast, with a beautiful liftoff of Electron from the pad at Launch Complex 1. We're now T plus 40 seconds into the mission and approaching max Q, or maximum aerodynamic pressure, at the 1 minute 9 mark. Max Q is the moment during launch when Electron experiences the highest amount of mechanical stress from the dynamic pressure, which is a function of its velocity and altitude. We'll be coming up on max Q in just a few seconds.
Vehicle past maximum dynamic pressure.
And there's the call that we've successfully cleared max Q. All is looking good with our trajectory, and Electron is performing nominally.
Stage 1 guidance is nominal.
AOS Chatham Station.
We're quickly approaching the next set of milestones in this mission. First up will be main engine cutoff of the 9 Rutherford engines on Electron's first stage. This is when the engines throttle down before the vehicle separates into sections, or what we call stages. Following that, the sole vacuum-optimized Rutherford engine on that second stage will fire up to continue the journey to low Earth orbit. We're a few seconds away from those events, and those calls will come in quick succession, so we're going to cross back to mission control now.
Stage separation successful.
Stage 2 ignition confirmed.
And you've seen it on your screen there. We have had a successful MECO, first and second stage separation and ignition of the Rutherford engine on Electron's second stage. Coming up in a few seconds, Electron's fairing will separate. The fairing is the casing at the top of the rocket that protects the satellites as they travel through Earth's atmosphere.
Fairing jettison succeeded.
And,
High voltage battery discharge.
and there they go. The fairing has cleanly separated and
Stage 2
fallen away
propulsion
from
is nominal.
Electron, which is continuing on a nominal trajectory.
Stage 2 guidance is nominal.
Electron's trajectory continues, as you'll often hear us say, nominally, with a current speed of just under 10,000 kilometers per hour and an altitude of about 165 kilometers, and we are now at about 4 minutes into the mission.
Some absolutely stunning views of Earth from Electron's Stage 2 camera. The journey toward low Earth orbit is going smoothly so far, and we're about a minute away from battery hot swap.
Starting throttle down on stage 2.
Stage 2 propulsion remains nominal.
High voltage battery discharge nominal. Approaching hot swap.
As we mentioned before, in the next few moments we'll be coming up to the battery hot swap, a maneuver that's very specific to the Electron rocket as the only launch vehicle flying with battery-powered electric pumps feeding our engines. When the first set of batteries are depleted during launch, we switch to a fresh one to power the engine for the rest of the mission. Sometimes you can see those battery packs fall away after the event, so let's keep an eye on the live feed from Electron and listen into mission control for the call.
Battery jettison confirmed.
Propulsion remains nominal.
Hot swap.
And there we go, that's confirmation that the battery hot swap was performed successfully on Electron, and propulsion continues to look good for the rocket's second stage Rutherford engine. We're just a few minutes away from orbital insertion and kick stage separation on this mission. Electron is currently travelling at over 15,000 kilometers an hour and at an altitude of 276 kilometers above us.
Current altitude is 280 kilometers, speed 4.9 kilometers per second.
If you're just joining us, we have had a successful liftoff of our They Go Up So Fast mission. About 2.5 minutes into flight, we had main engine cutoff, stage separation, and stage 2 ignition. We're coming up on separation of the kick stage at around T plus 9 minutes. The view on your screen is Electron's second stage Rutherford engine. This engine is the same as the 9 engines that lift Electron off the pad, but with an extended engine nozzle for optimized performance in the vacuum of space. We are looking good for SECO or second engine cutoff shortly.
And we entered stage 2 burnout detect mode.
Shortly, Electron will shut down the Stage 2 Rutherford engine to allow for a clean separation of the kick stage. That will place the kick stage in an elliptical orbit around the Earth for a coasting period of around 40 minutes or so. That event is coming up shortly, so we're going to switch back to mission control to await the confirmation.
Stage 2 guidance is in terminal, 10 seconds remaining.
SECO confirmed.
And stage 2 separation confirmed. And now transfer over to capstone.
Fantastic news that the Rutherford engine on the second stage has successfully shut down as planned and the kick stage has cleanly separated.
The kick stage is now going into its coasting phase for about 40 minutes or so while we wait for the circularization burn from our innovative Curie engine. In the meantime, we're going to take a small break, and you can join us back here in about 10 minutes as we're joined by Rocket Lab founder and CEO Peter Beck to answer some questions about our Neutron program. We'll be right back.
Hello again, welcome back, and thank you for joining us for this 19th Electron mission. Electron successfully lifted off at 11:30 local time and completed all of the key milestones of launch, including passing through max Q, main engine cutoff, first and second stage separation, ignition and burn of the second stage, and final separation of the kick stage from Electron ahead of payload deployment. Right now we're in a coasting phase, heading to the optimal position above Earth to deploy the 6 satellites on this mission, expected to occur in about 40 minutes or so. But while we wait, I am joined here in the studio by Rocket Lab founder and CEO Peter Beck to talk about our new rocket joining our launch vehicle family, Neutron. Peter, thanks for taking the time out of Mission Control to talk to me.
My pleasure, Mira.
Now, for those of you who might not be familiar with Neutron, Peter, why don't you tell us about the new rocket and why right now is the good time to build it?
Yeah, I mean, we spend quite a lot of time with Electron launching our customers, and Electron's been a fantastic vehicle to really pathfind a lot of constellations for our customers. So the conversation sort of went like, look, Pete, thanks very much for getting our first one in orbit, but actually now we've got a whole bunch of them we need to get there. Mm-hmm. So it became really, really obvious that there's a really, massive need in the marketplace for, for a vehicle specifically built for launching, mega constellations and constellations.
Mm-hmm. So you've talked about Neutron as a constellation builder, but what makes it ideal for that?
Yeah, well, I mean, it's right-sized. So, if you look at all the constellations that are in development in various forms, they all fall around a similar kind of mass class. And that 8 tons to orbit is really the ideal mass class, for building mega constellations. But not just mega constellations, in fact. If you look back through history, the average payload, mass lifted by all launch vehicles in all of history is between sort of 4 and 5 tons. So we think this is the right time to bring a vehicle that's right sized to the market.
Cool. And what can you tell us about Neutron's engines?
Not a lot. It's a secret. No, I mean there's areas that we're innovating and there's areas that we're not innovating. The engines always deserve their own name, so they certainly deserve their own limelight as well. So we'll make a little bit more announcement about engines in the appropriate time.
It'll be fun brainstorming some new names for those engines, I'm sure.
Oh, it's already named.
Have you? So tell me why you've selected Wallops as the launch site for Neutron.
Yeah, so Wallops is actually it's a fantastic mid-inclination site, and mid-inclination is really, really important for the majority of launch. We're able to leverage Pad 0A and the wonderful team there at Virginia and Wallops Island. Obviously we have the home of Electron there, so it made perfect sense to also put Neutron there as well. And one of the interesting things that if you start to look at launch vehicle design, you find a lot of launch vehicles kind of asymptote around that 3.9 metre diameter, and that 3.9 metre diameter is really a function of the lowest bridge between California and Florida. So we didn't want to use that as a design constraint for Neutron. So
makes sense.
Yeah, so we were looking for a launch site that we could also manufacture near as well.
Cool. And what is the biggest hurdle for you at the moment for Neutron's development?
Well, the biggest hurdle is for Rocket Lab is always talent. So I don't want to turn this into a shameless talent plug, but I mean, in all honesty, that has always been our throttle, is how quickly we can onboard people. The bar is high, and we're unashamedable that the bar is incredibly high at the company. But that always is our throttle in developing any of Rocket Lab's programs.
There's a few hundred jobs expected to be created for this one, isn't there?
Yeah, absolutely. Yeah. Both in Virginia and New Zealand, and in fact, in every one of our locations, I think that is our throttle.
Sure. And how is the hat? Do you expect to be eating any more anytime soon?
Well, that's why I made sure that we talked about human spaceflight and all of the things that we could possibly do in the future in one hit, because that hat was just not tasty. And as you know, Muriel, it took 2 takes, so there was actually 2 hats consumed in the making of that video. So, not looking for that again.
Also, Neutron's capabilities, it's going to be reusable, isn't it?
Yeah, so that's probably the biggest fundamental difference between Electron and Neutron. So, Electron was all about how do we make the most manufacturable rocket. Neutron is how do we make the most reusable rocket. There's a bunch of things about, especially the first stage, that as we announce a little bit more about the program, people will be, I think, quite surprised with some of the innovation that's in that first stage. Because it really is, it really is about how do we make the most reusable, not serviceable, the most reusable launch vehicle in the world.
And speaking of recovery, can you tell us anything more about when we'll next see another Electron under a parachute?
Yeah, not too many missions away actually. So I was down sitting inside the stage there earlier in the week, and it's looking super good. So parachute was about to be packed into the stage, and all of the little thrusters and everything were on it. So it's all looking very good. And the next recovery mission is with a significantly upgraded heat shield. So the previous recovery missions have been basically, with upgraded block upgrade of stage 1 with reaction control systems and guidance systems and things like that. But we never really addressed the handling the thermal loads that we expected, because there was kind of no point, because unless you can control the entry of the stage, it's kind of irrelevant. So this one has a much more significantly upgraded heat shield, and so we're expecting much better performance and hopefully much better condition of the stage when we go and pick it back up.
How exciting. Any helicopters with this one? Will you be piloting a helicopter?
No, I'm nowhere near good enough to I'm kidding myself to think that I was a good enough pilot to catch one. But no helicopters in this mission. Basically, we're going to splash them down in the ocean until such a point as actually the stage is what we would consider completely reusable. At that point, we'll bring in that extra element of logistics with helicopters.
Very nice. Hey, thank you, Peter, so much for joining me here. It's such an exciting time to be part of the team, and I personally can't wait to be front row and centre to watch Neutron launch from Virginia.
Yep, no, it'll be great. Thanks very much.
Now, back to the mission at hand, of course. We have another 40 minutes or so to go until the first payload deployment for They Go Up So Fast. This coasting graphic will keep us on track for where above the world is the kick stage, and we'll be back on your screens as we gear up for that first deployment, so see you shortly.
Hey, and welcome back. Thank you for joining us for the 19th Electron mission. If you're just now joining us, we've had a successful liftoff. Everything has gone nominally, and we're currently in our coasting phase of our kick stage, waiting for the Curie engine kickoff. So that'll be approaching at about T plus 59 minutes, and we'll be burning for about a minute. And then we'll just be waiting for mission control to hear those calls and get a successful relight here momentarily. So stick with us, and we'll be checking back in shortly.
Hello and welcome back to Rocket Lab's mission. They go up so fast. If you're just joining us, Electron successfully launched today at 11:30 local time from Rocket Lab Launch Complex 1 in New Zealand. We completed first and second stage separation, successful ignition and burn of the stage 2 Rutherford engine, and then a final separation of the kick stage ahead of payload deployment. Very soon, this third stage of the rocket will perform a short burn of its Curie engine to circularize its path around Earth, ready to release this mission's satellites to their ideal positions. We are at T plus 47 minutes into the mission, and we're just waiting now for that engine burn, which is expected to occur shortly.
returning mission confirmed.
While we're waiting for the Curie burn to finish, I'm going to tell you a bit more about what will happen next for our customer satellites. With 4 of the satellites on this mission set to join their respective small-sat constellations, pinpoint payload deployment is absolutely critical. The ability of the kick stage and Photon's Curie engine to perform multiple relights means we can be very specific about where all of these satellites are deployed, even though they're all flying on the same vehicle. First, Photon, operating as a kick stage at the start of the mission, will deliver the majority of the satellites to a 550-kilometer circular orbit. That deployment will occur over a period of around 5 minutes or so. Then, with a short burn of the Curie, Photon will actually lower its altitude 100 kilometers closer to Earth to deploy the final payload to a 450-kilometer orbit.
But even then, we are still not done, because after payload deployment, our operators in mission control will issue a command to transition the kick stage into spacecraft mode and begin our secondary mission objective to test out new systems on our own satellite. This Photon will build flight heritage across its subsystems for our capstone mission to the Moon for NASA this year, as well as our private mission to Venus in 2023. We've got some new and exciting technology to demonstrate on Photon this time, including deep space radio capability, sun sensors and star trackers, and an upgraded reaction control system for precision pointing in space. We're coming up to the release of the first satellite from Electron shortly, so let's listen in for the calls from mission control. So we've had confirmation that the first satellite has been deployed from Electron, the M2 smallsat from the University of New South Wales, Canberra Space in Australia.
Up next is the Centauri 3 Internet of Things nanosat from Fleet Space. And there we go. We have confirmation of another successful deployment, this time for Fleet Space. 2 down, 3 to go at this orbit. The Viri Hatchling 1U CubeSat from CareWeather is up next. CareWeather is focused on saving lives through better forecasting of Earth's extreme weather.
Now what you're seeing on your screen is a simulation of payload deployment. We will confirm all payload deployments on our social media channels shortly. Great, and there is the third payload deployed from Electron. This one is tiny, it's about the size of a bagel. But next up is the small sat for SMDC. This one is the size of a loaf of bread and is being deployed by Rocket Lab's Maxwell CubeSat dispenser.
And as you can see in the simulation, the payload from the US Army's SMDC has been deployed to its 550-kilometer low Earth orbit. The final payload at this orbit is up next, and it's the Myriota 7 satellite.
We are just waiting now for the deployment of the Myriota satellite. And there it goes, that's the 5th satellite on this mission deployed. The Myriota has been deployed to its orbit as planned.
Congratulations to all of our mission partners so far, and let me be the first to welcome you to your new home in orbit above the Earth. We have one final payload to deploy on this mission, the Gen 2 spacecraft from Black Sky Global. But as we've mentioned before, we have to drop the kick stage to a lower orbit first.
We'll do this with a second relight of the Curie engine to change the kick stage's altitude, and 40 minutes or so after that event, Curie will be ignited for a third time to circularize its orbit around the planet at 450 kilometers above us. Then soon after that, kick stage will transition to photon mode and remain in that orbit to test out some of the spacecraft's new technologies.
We won't be live for confirmation of payload deployment, but it should look something like this. Keep an eye out on our social media channels for verification of final payload deployment and the transition to Photon later today.
Now, before we close out the webcast, I want to remind you that we are still actively recruiting for over 90 roles across the Rocket Lab team. So if you've ever wanted a career in space, there is no better time than now. Head to rocketlabusa.com for more information. And a huge congratulations to the entire Rocket Lab team on reaching this awesome milestone of over 100 satellites on orbit. And a huge thank you, of course, to our mission partners for choosing Electron to fly on your mission. And a final thanks to you for joining us for this launch. I'm Muriel Baker.
And I'm Scott Moeller. This is Rocket Lab Mission Control, signing off.